Okay, so in this section, what we're going to be talking about is, remember last time we talked about functions. This time what we're going to talk about is something that is known as the domain and the range of any particular function when we look at it, or non-function to be honest. Any type of equation that we're going to look at, we're going to be talking about what is known as the domain and the range, okay? So the domain is basically, one really good way to look at the domain, and you have to keep in mind when we're talking about both of these things, that by and large, we can use anything for our domain and our range. So don't get the idea that when we talk about these things that we're really restricted as to what we can use. And I know that doesn't make sense because we haven't talked about them yet, but it will as we kind of move on. The first thing obviously we're going to talk about here is the domain. The domain is simply all of the outputs, or all of the inputs we can use, excuse me. Any input that we can use is what is known as the domain. So all of the inputs. We talked about inputs versus outputs last time when it came to a function. Okay, so that's all of the inputs. And a really good way to look at that, because of the way that we look at these problems in general, we are going to say that is all of our x values. If you remember, we said that most functions when we're looking at them start off written something like this, y equals 2x plus 4. So this is saying what are all of the numbers that it's possible that I can put into that equation to get my outputs. What are all my inputs? And like I said, by and large, you're totally fine plugging any number in that you want to find out what your domain is. So in this case, I could plug in any number I wanted to into x, and I wouldn't have to worry about it. Now, there are only a couple things that we have to worry about. We're going to talk about those things in just a second. But past that, again, you can use just about any x value you want. You're totally fine. The range is all of the outputs that you can get. Now, range works a little bit differently than domain, and we'll see this in a little bit, but this is basically all of your y values. All of your outputs are your range. Okay, and when we look at these things, again, we have to remember that by and large, I can use most numbers. So let's kind of move a step further and let's say, whoops. So let's look at these. Okay, here's my domain, and these are examples that are not equations. Okay, and examples that are equations versus not equations are a little bit different. So the first thing I want to talk about is if we have like a limited amount of numbers. Like, for example, this mapping that we have right here. You'll notice this first section is our input, because that has the arrows pointing to all the different numbers. So our domain of this particular function would just be all of the numbers that are in that particular circle. Okay, so that is my domain. 1, 2, 3, 4, 5. And then the range is just all of the numbers that exist on the other side. Okay, so I've got 3, 4, 5, 6, 7. Now sometimes, it depends on what you're looking at, but in this particular example, because we only have numbers that only have certain numbers with arrows on them, those are the numbers that we really count as numbers in our domain. So 1 and 2 don't have arrows, excuse me, coming from them, so I would get them out of my domain, because we're not talking about those numbers this time. I'm not putting those numbers in. Even though they're in that circle, they're not being put into whatever it is we're looking at. And then the output, as you can see, arrows are pointing to everything but 7, so it would be 3, 4, 5, and 6. That is my range. Now, it's a little bit confusing. I've never really seen one exactly like that, so I wouldn't worry about it too much. More, I've seen them like this. You'll notice 1, 2, 3, 4, 5 are all of my inputs. Those are all of my x values. So those numbers, if I were to write them down, would be my domain. All of these numbers here would be my range. So that's the way that we look at domain and range when we have a table or a chart like this, is all of the x values are my domain, all of the y values are my range. Down here where we have different ordered pairs, and these are just a bunch of different points that it would exist on a graph, if you will. Again, all of the x values, I'm just going to write domain as a D. All of the x values would be my domain. So in this case, I'd get 4, 3, 1, 7. No, this is supposed to be a comma here. 7 and 6. And you can reorder them if you want to and put them in order from least to greatest. It doesn't matter. That's still our domain. And our range is all of the y values. So I would say that's 7, 9, 8, 5, 2. So that's my domain and my range when I have a set of ordered pairs. Again, just all of the x values and all of the y values. Now, when we start looking at a picture of a graph like this one right here, all of a sudden this becomes a little bit more difficult because technically there are a ton of different x values and a ton of different y values. Like on this graph, you'll notice this first point that I have here is the point 1, 3, and the point at the end is the point 5, 0. So I could say, if I was looking at this graph, I could say, okay, I have 1. The point 1 is one of my x values, then 1.1, 1.2, 1.3. But there's a million different numbers that we would have, and I don't want to have to write all of them down. And so what we do, if we don't want to write them all down, is we say, okay, I'm going to say all of the numbers from 1, x equals 1, to x equals 5. And if you want to write it down that way, that's totally fine. The way that math people like to write it, because they really don't like to write stuff if they don't have to, the way that math people write it is they say, okay, I'm going to put a 1, and then I'm going to put a comma, and then I'm going to put a 5. That indicates I'm starting at 1, and I'm ending at 5, and I'm talking about every single number that exists in between those two. And then what we would do, you've talked about this before, you look at the end points and see if they're filled in versus if they're not. If they're filled in, we put a bracket next to that number in both cases. So in this case, my domain would be every number from x equals 1 to x equals 5. My range on that same problem, again, when we talk about ranges, we would say, okay, the lowest point on this graph where my y values start is at 0. So I could technically say it is from y equals 0 all the way up to y equals, the highest this graph goes is 3. And there's a bunch of different numbers between 0 and 3 that we could include, but I don't want to have to write all of them down. So instead of writing from y equals 0 to y equals 3, I can write that again using these brackets because those circles are filled in. I could say from 0 to 3. That's how we write it in math. It means exactly the same thing. It's just a different way of writing it that's a little bit easier so you don't waste as much ink. So here's another picture, and this one's kind of interesting because you'll notice on the end of this graph there are arrows. Those arrows, if you ever see them, mean that the graph is going forever in that direction. So in this case, because that arrow's there, it's going in that direction forever and it's going up forever. This graph is moving to the left forever, and again, it's moving up forever. So if I was talking about the domain on this particular graph, I would say, okay, what is the smallest x value that I see on this graph? Now, the entire graph is not drawn. The graph goes in both directions forever and ever and ever. So in this case, I would say that my domain starts all the way over as far as I can go to the left. Well, if we're talking about all the way over as far as I can go to the left, that is what is known as negative infinity. And then if I go all the way over to the right, that means I'm going to positive infinity. And because infinity, we've talked about it a little bit before, I hope, infinity is not a number, so we can't put a bracket around it. We put a parenthesis around it, meaning we're not including it. And that's what we say our domain is. If our domain goes all the way in both directions forever and ever, we just say that it goes from negative infinity to positive infinity. And what that means is we are going from the farthest to the left the graph would go forever and ever and ever to the farthest to the right the graph would go. The range is very similar, except we have to realize one thing. There is a bottom point on this graph. The smallest y value that is on this graph is negative 15. And because that is a filled-in circle there, I would put a bracket around it. And then this graph goes up forever and ever and ever. Because the graph goes up forever and ever and ever, we would say that the range on this is infinity, in that it keeps going up and up and up and up and up and up, and it never stops. So that's how we find domain and range on a graph. Now, there are a couple things that you can't do in math that I want to discuss right now. The first thing that we cannot ever do is divide by 0. You can't do that because if you have 0 of something, you can't divide it into even parts. The second thing that we can't do, although this will change as we talk a little bit, but right now just kind of take my word for it, is we cannot take the square root of a negative. If I have either of those things, either of those situations pop up, I need to make sure that I don't use those numbers in my input. So I want to avoid those numbers when I'm talking about my domain. So for example, I've got this problem right here. I've got a function 3 minus x over x minus 2. If I'm looking for the domain, I would say that I'm good to go, and you're almost always good to go, Except you'll notice on the bottom here, there is one number that if I put it in for x, I would be dividing by 0. And that number is x is equal to 2. If I took 2 and substituted it into this function, I would see that I've got 2 minus 2, which gives me 0 on the bottom, and I want to avoid that. I cannot divide by 0. So what I would say is my domain is all real numbers. That means I can use every single number except x equals 2. Or we can just say x does not equal 2 and we're good to go. Okay, so that is how we deal with any number when we're dividing. And there's an x on the bottom. I want to avoid any number that would make the bottom of a fraction be 0. Because then I would be dividing by 0, and we just learned we cannot do that because you can't divide something in zero somethings into any parts at all. The other thing that we are going to do is we're going to look at when we see a square root. I want to make sure that I'm not taking the square root of a negative number, and the way that we do that is we take whatever is underneath the square root and we set it greater than or equal to 0. Now, anytime you have a greater than or equal to sign, you just treat it like an equal sign in that we're going to solve. So I'm going to subtract 5 from both sides. So in this case, I know that my x has to be greater than or equal to -5. What that's saying is if I plug in a number that is less than -5, I know for a fact that I cannot do that because I cannot take the square root of a negative number. So there's 2 examples of finding the domain, and that's what you always do. If you're dividing by something that has an x in it, figure out what's going to make the bottom equal to 0 and avoid that number. If you have a square root, take what is underneath the square root, set it greater than or equal to 0 so you know which numbers you can use. Now range is a little bit different. Range, you just have to you have to know what the graph looks like. So basically you would graph all of these on your calculator to know what the range is. X plus 5, if you were to graph that on your calculator, would just be a line that looks like this. And if you don't know how to graph on your calculator, your teacher will help you with that. That's not that big of a deal. But that is what that line would look like. You'll notice that that line starts at -infinity and goes all the way to +infinity. And so I know for a fact that that range, is from -infinity to infinity. X squared, again, graph it on your calculator. It looks something like this. And again, your teacher can help you if you need to. The graph looks like that. You'll notice this time the range, this graph does not go down forever and ever and ever. The lowest point on it is y equals 0, and then the graph goes up and up and up all the way to +infinity. Lastly, x plus 5, and we've got the absolute value, is a graph, 3, 4, 5, that looks like this. If I was to graph that on my calculator. Again, even though the graph has been shifted left and right, you'll notice that I can still go from 0 to infinity. Range other than that is fairly difficult to find because you have to know certain characteristics of certain graphs. So rather than do that, this is some practice you can get using your graphing calculator and to see what these graphs look like, and then from there we can define what the range is. Hopefully that made sense. Domain's a little bit easier to do by hand. Range is a little bit easier when you use your calculator. But both of them, just don't forget, domain is always all of the x values or all of the inputs, and the range is all of the y values or all of the outputs. Hopefully that makes sense. If you have any questions, please ask your teacher. Good luck.